look at the second problem over here. We also use the area method to find the value of the definite integral. So let's again sketch the function's graph first. Okay, so we have over here between negative infinity and 0, we have function's value 0 over here, 0 over here. And then between 0 and infinity, we have 45 degrees. So this is a function. And we have over here, this is x, and this is f of x. Okay. So this is the function's graph. And then we want to integrate from negative 10 to somewhere s. But the tricky thing is we don't know where s is. So is s over here? Is s over here? Or somewhere actually even further? So we're going to actually divide them into cases because we have different shapes over here to find the area. So we see the following thing. Look at this integral from negative 10 and s, f of x, and dx. And we realize if s is less than or equal to 0, the function's value is actually 0. So what we have over here, this is case 1. Okay, this is equal to negative 10 to s and 0 dx if s is less than or equal to 0. And that's very important because your function is piecewise, so we have to somehow be careful what kind of interval we have, or what kind of values this s is taking. Now, if everything is 0, of course, the integral is going to be 0. So case number 2. This is case number 2. This is case 1. Okay. And so what we have over here is still negative 10 to s and f of x and dx. Okay. Now, we have the case when s is bigger than 0. So what we have is negative 10 to 0, 0 dx. And plus from 0 to s, and we have over here, now we have x dx. Now, we can easily use the area of the triangle to find this integral. This first part is equal to 0, and this part over here is 1/2, base is s, and times the height is also s. So the value we have over here is simply going to be 1/2 s squared. Now we can write down the entire expression in terms of a piecewise defined function. So negative 10 to s f of x dx is equal to 0 if s less than or equal to 0, and is equal to 1/2 s squared if s is bigger than 0. And that would complete this problem. If we look back in problem 2, we used the property so-called interval additivity. If you have a function which is defined piecewise, you need to divide the interval into certain number of pieces according to what you have for your function f of x. And that is all.